Hi everyone. Previously, we have looked at the cosine rule and solved some problems using the cosine rule. Cosine rule comes from a branch of mathematics called trigonometry. Today, we are going to look at the sine rule. Just to refresh our memory, you can recall that if you are given, this is not writing. If you are given a triangle of this form, this is, label it as A here, B here, and C here. There's an angle here, another angle here, another angle here. The angle inside here, we call it angle I, capital A, since this point is represented by A. Similarly, capital B here, capital C here. So the side opposite this angle A, that is this side here, call it small letter A. Similarly for B, call it small letter B, and similarly here C. So now if you want to establish the cosine formula here, if you are given the other components but you are asked to determine, for example, this side, which is A, this triangle, according to the cosine rule, you will have A squared equals B squared, now this side, plus C squared, that side, minus 2BC, the cosine of A. This angle here, the opposite side, the square of it, and then you have the adjacent sides to this angle. Square them, minus twice their product, then multiply by the cosine of this angle. Similarly, for B, if we want to find this length B, this will give us now A squared plus C squared minus 2AC, the cosine of B. If you have A, it will end with angle A. B, it will end with angle B. Likewise, C, this side, now, squared is equals to A squared plus B squared minus 2AB, the cosine of C. These three formulae form the cosine rule, and it's very important in navigation for pilots especially. So now, what about, this is the cosine, yeah, the cosine rule, don't forget. What about the sine rule? What does it tell us? The sine rule is applicable when you are given in a triangle, you are given two sides and one angle, and then you are asked to find the fourth angle. Or you are given two angles and one side, and then you are asked to find the remaining side. That is when the sine rule is mostly applicable. So what we are going to do this morning is to derive the sine rule. We've done this, we derive these formulas here. I just recall them to refresh our memory. Now we are going to look at the sine rule. Still have our B here. So again, imagine you are given a triangle like this one here we have on the board. And we want to establish the sine rule here. So our first approach is to draw a perpendicular line from B to AC. And we'll name this line, the height of this line, as H. We'll do this to divide this triangle into two right angled triangles. Why? Because when we want to use all those trigonometric identities, sine theta equals opposite over hypotenuse, the cosine of theta equals adjacent over hypotenuse, and the tangent of theta equals to opposite over adjacent, these three trigonometric identities are only applicable in a triangle when one of the angles in that triangle is 90 degrees. In other words, they are only applicable in a right angle triangle. But what we have here, disregard this perpendicular line. This is a triangle. It could be an isosceles triangle, a scalene triangle, or equilateral triangle. We don't want to go into that, but this is just a triangle. And guys, you can't use those three trigonometric identities I've just mentioned to solve this side, except you do some manipulation here, which we have already started to do by drawing a perpendicular line from B to the line AC. So now what we have here, we have now split this whole triangle into two right angles triangle. If you consider this one here now, you have this triangle, which is A, B, and if I name this M, I have it as M. I'll put this one here. Still have an angle here. And still have this one here. This represents a right angle triangle. And the flip side, you have this one. You have N still. You still have your B here, and you have your C here. This again is a right angle triangle. The right angle triangle is now easy for us to say the sine of theta, for example, is equals to opposite all over hypotenuse. Cosine of theta is equals to adjacent all over hypotenuse, and the tangent of theta is equals to opposite all over adjacent. We can then use these ones here. So that is what we want to do. That's why we split this, we draw this perpendicular line from B to the line AC. So let's see what we can get from it. If we now consider triangle BAN, consider now triangle, this is sign for triangle, BAN, we are looking at this triangle BAN. What was BAN? We are looking at this triangle now. So what is H in this case? You know now that this is, the angle is here, okay? So if we say the sine of I, this is equals to the opposite, which is H in this case, all over the hypotenuse side, which is C. Correct? So this gives us C, the sine of angle A equals H. Let's consider now this second triangle, triangle BCN. There we have the sine of C. Sine C is opposite divided by the hypotenuse, which is h again divided by hypotenuse, in this case is I. So therefore cross multiply, you will get I sine of c equals h. We say this is equation 1, this is equation 2. You know, in mathematics, when you have two different things equal to the same thing, it means those two different things are themselves equal. What we are saying here, if c sine a equals to h and a sine c equals to h, this is h, this is h. This implies that c sine a equals a sine c. Since h is equals to this, h is also equal to this, it means this is equals to this. That's the logic of mathematics. So therefore, now we can say that equation 1 is equals to equation 2. Since h is equals to h here, which means we have c, the sine of angle A, equals small a, mind you, the sine of angle big C. Right? We now have this. So, if I divide both sides by I, small a, mind you, the small a is the length, big A is the angle. If I now divide both sides of this equation by A, you know, this A will cancel. You will now have here C, the sine of A all over A is equals to sine of C. I'm not done yet. I now want to divide by C because I see C here. I don't want C to be here. I want C to join its neighbor. So if I divide both sides by C, I'm going to get here C sine of A all over C times A. I'm dividing both sides by C. I'm going to have here sine C all over C. So the C's here will cancel. So I'll now have sine of A all over A equals sine of C all over C. We have established the cosine rule. This is the cosine rule. So if we now want to, what is missing here? B, sine B over B. So what do you do? How to get sine B over B? If I move C here, I move B here, and I move I here, I do exactly what I've done. You will get this to be sine of B all over B. We now have sine of A, sine I over A equals sine C over C, cosine sine B over B. This forms the sine rule. So if, let me take this off. If the sine rule can be written like this, we can claim that it can also be written in this form. A over sine of A equals B all over sine of B equals C all over sine of C. As long as you are consistent. Here, the sides are at the bottom. A, B, C at the bottom. Here, the sides are at the top. Just flip it. As long as you are consistent, then this also holds true. So this forms the sine rule. In the next video, we are going to solve problem using the sine rule. Thank you for watching. Bye bye for now.